everyone, welcome to our class 4.
Our class 4 topic is other celestial bodies, space debris and artificial satellites.
Welcome to our amazing learning journey of other celestial objects in the solar system.
Let's move to the journey. A celestial object is a naturally happening phenomenon that occurs in the observable universe. In astronomy, the word object and body are often used interchangeably. On the other hand, a celestial body is a solo, strongly bound, adjoining entity, while a celestial object is a complex, less cohesively bound structure which may consist of multiple bodies or even other objects with substructures. Celestial bodies or heavenly groups are objects in space such as the sun, planets, moon and stars. Main classification of celestial bodies are stars, planets, satellites, comets, asteroids, meteor and meteorites, galaxies.
Stars. Stars are giant balls of hot gas that can produce their own light. Stars give out energy by converting hydrogen gas into helium in their cores. The sun is also a medium-sized star that gives us energy and makes life possible on Earth. Planets are large, almost spherical objects that revolve around the sun. Planets move in fixed orbits around the sun. There are 8 planets in our solar system. They may be made of rocks, metals and gases like hydrogen, nitrogen and methane. The Earth is also a planet and is the only known place in the universe which supports life. The planets that revolve around other stars are called exoplanets. Satellites are objects that revolve around planets. They form the essential part of the celestial bodies. They may be of natural origin or sent by humans. The moon is the natural satellite of the Earth and it revolves around it because it is bound by the Earth's gravitational pull. Man has also placed artificial or man-made satellites around Earth and other planets to study them and for communication purposes.
Comets. These are small chunks of ice and rock that come from the outer edge of the solar system. When its orbit brings it closer to the sun, the ice on them vaporizes, creating a beautiful tail behind them. Asteroids. These are small irregularly shaped rocks made up of metal or minerals that orbit the sun. Most of them are found between Mars and Jupiter in an area known as the asteroid belt. Meteors and meteorites. These are objects from space that enter our atmosphere as they are pulled by the Earth's gravity. Meteors usually are small and burn up in the atmosphere as they enter the Earth. This creates streaks in the sky as though a star has fallen. They are commonly called shooting stars. If a meteor is large enough, it can reach the ground and create a crater. Such objects are called meteorites. Galaxies. Galaxies are large groups of stars held together by gravity. The Sun and the solar system is part of a galaxy known as the Milky Way. Other galaxies are usually so far away that they look like stars in the night sky. The Andromeda Galaxy and the Large Magellanic Cloud are galaxies that can be seen with the naked eye on a clear night.
Celestial bodies form a part of the massive universe we live in and are typically very far from us. The magnificent night sky is dotted with such objects, and when we see them using a telescope, they expose fascinating worlds of their own. Because they are so far away, we cannot see all of them with the naked eye and we depend upon telescopes to study them. The word celestial body is as wide as the entire universe for both known and unknown. By definition, a celestial body is any natural object outside of the Earth's atmosphere. Simple examples are the moon, sun and the other planets of our solar system. But those are very partial examples. The Kuiper belt holds many celestial bodies. Any asteroid in space is a celestial body.
Now, let us move into the details of each topic. Let us see what our friends are going to share about asteroids.
Asteroids, sometimes called minor planets or rocky, airless remnants left over from the early formation of our solar system about 4.6 billion years ago. The current known asteroid count is 11,000,000 7,640. Most of this ancient space travel can be found orbiting our Sun between Mars and Jupiter within the main asteroid belt. Asteroid range in size from Vesta, the largest, at about 329 miles in diameter, two bodies that are less than 23 feet across. The total mass of all the asteroids combined is less than that of the Earth's moon. Most asteroids are irregularly shaped, though a few are nearly spherical, and they are often pitted or cratered. As they revolve around the Sun in elliptical orbits, the asteroids also rotate, sometimes quite erratically, trembling as they go. More than 150 asteroids are known to have a small companion moon. Some have two moons.
There are also binary double asteroids in which two rocky bodies are roughly equal size orbit each other, as well as triple asteroid systems. The three broad composition classes of asteroids are C, S, and M types. The C-type chondrite asteroids are most common. They probably consist of clay and silicate rocks and are dark in appearance. They are among the most ancient objects in the solar system. The S-types, stony, are made up of silicate materials and nickel iron. The M-types are metallic nickel iron. The asteroids' compositional differences are related to how far from the Sun they formed.
Trojans. This asteroid share an orbit with a larger planet but do not collide with it because they gather around two special places in the orbit. There, the gravitational pull from the Sun and the planet are balanced by the Trojan's tendency to otherwise fly out of the orbit. The Jupiter Trojans form the most significant population of Trojan asteroids. It is thought that they are as numerous as the asteroid in asteroid belt. There are Mars and Neptune Trojans, and NASA announced the discovery of an Earth Trojan in 2011. Near Earth asteroids. These objects have orbits that pass close by that of Earth. Asteroids that actually cross the Earth's orbital path are known as Earth crossers.
The International Astronomical Union's Committee on Small Body Nomenclatures is not very strict when it comes to naming asteroids. As a result, out there orbiting the Sun, we have a giant space rock named for Mr. Spock, a cat named for the character of Star Trek fame. There's also a space rock named for the late rock musician Frank Zappa. There are more somber tributes too. Asteroids are also given a number, for example, 99,942 forces.
Let us do an experiment on impact. Consider this to be a rock. Consider this to be soil. Consider this to be the meteorite. So, what happens if the bad scenario happens that the asteroid hits Earth? When smoke rise in the atmosphere, this prevents the sunlight not to come to our world. This also causes the temperature to drop. This also causes the death of many living beings. And if the asteroid was big as an apartment, when it hits the Earth, it would possibly destroy a small city. But if the asteroid was a 20-story building size, and when it hits the Earth, it would possibly flatten a small country.
Acraman crater. Asteroid impact date estimated 580 billion years ago. Location South Australia. Specification located in what is now Lake Acraman. This impact structure has an estimated diameter of 90 kilometers.
Kogan crater. Asteroid impact date estimated 250 million years ago. Location Quebec, Canada. This impact crater formed what is now Lake Manicogan. Even with its erosion, it's considered one of the largest and best preserved craters on Earth, with an estimated diameter of 62 miles.
Morgan crater asteroid impact date is around 145 million years ago. The Morgan crater is located near the Kalahari Desert in South Africa. It contains the fossilized remains of the meteorite that created it. Kara crater asteroid impact date is around 70.3 million years ago. The Kara crater is located at Nanisha in Russia. Kara crater is very eroded and non-exposed structure. It is said that it has 2 craters.
We have learnt a lot about asteroids. Now let's move to meteoroids, meteors and meteorites.
Introduction of meteorites, meteors, meteorite. They're all related to flashes of light called shooting stars, sometimes seen streaking across the sky. But we call the same object by different names depending on where it is. Meteorites are what we call space rocks that range in size from dust grains to small asteroids. This term only applies when they're in space. Most are pieces of other larger bodies that have been broken off or blasted off. Some come from comets, others from asteroids, some even come from the moon or other planets. Some meteorites are rocky, while the others are metallic or combinations of rock and metal.
When meteorites enter Earth's atmosphere or that of another planet like Mars at high speed and burn up, they're called meteors. This is also when we refer to them as shooting stars. Sometimes, meteors can even appear brighter than Venus. That's when we call them fireballs. Scientists estimate about that 48.5 tons of meteoritic material falls on Earth each day. When a meteorite survives the trip through the atmosphere and hits the ground, it's called a meteorite. It can be difficult to distinguish a meteorite from an earth round by aliens in most parts of the world. But there are some special places where they're easier to identify: deserts. In sandy deserts with large open regions of sand and few rocks, dark meteorites stand out clearly. Similarly, meteorites can be much easier to spot in icy cold deserts such as frozen plains of Antarctica.
Most space rocks smaller than a football field will break apart in Earth's atmosphere. Traveling at tens of thousands of miles per hour, the object disintegrates as pressure exceeds the strength of the object, resulting in a bright flare. Typically, less than 5% of the original object will ever make it down to the ground. These meteoroids, pieces of meteor that are found, typically range between the size of a pebble and a fist. Meteorites that fall to the earth represent some of the original diverse materials that formed planets billions of years ago. By studying meteorites, we can learn about early condition and process in the solar system's history.
These include the age and composition of different planetary building blocks, the temperature achieved at the surfaces and interiors of asteroids, and the degree to which materials were shocked by impacts in the past.
Meteorites that fall to Earth represent some of the original diverse materials that formed planets billions of years ago. By studying meteorites, we can learn about early condition and process in the solar system history. These include the age and composition of different planetary building blocks, the temperature achieved at the surface and interiors of asteroids, and the degree to which materials were shocked by impacts in the past.
How do we know where meteorites come from? Most meteorites found on Earth come from shattered asteroids, although some come from Mars or the Moon. In theory, small pieces of Mercury or Venus could have also reached Earth, but none had been conclusively identified. Scientists can tell where meteorites originated based on several lines of evidence. They can use photographic observation of meteorites' falls to calculate orbit and project their path back to the asteroid belt. And they can also compare compositional properties of meteorites to the different classes of asteroids, and they can study how old the meteorites are, up to 4.6 billion years.
Now, let's move to the topic comets. Let us see what our friends are going to share.
Comets are frozen leftovers from the formation of the solar system, composed of dust, rock, and ices. They range from a few miles to tens of miles wide. But as they orbit closer to the sun, they heat up and spew gases and dust into a glowing head that can be larger than a planet. This material forms a tail that stretches millions of miles. Comets are cosmic snowballs of frozen gases, rock, and dust that orbit the sun. When frozen, they are the size of a small town. When a comet's orbit brings it close to the sun, it heats up and spews dust and gases into a giant glowing head larger than most planets. The dust and gases forms a tail that stretches away from the sun for millions of miles. There are likely billions of comets orbiting our sun in the Kuiper belt and even more distant Oort cloud.
What brings comet near Earth? Sometimes the gravitational pull of a passing star stirs up comets in the Oort cloud. Sometimes the gravitational pull of a planet can disturb comets in the Kuiper belt and flings one headlong toward the sun. The comet is pulled faster and faster toward the sun. It swings around close backside, then it heads out again to more or less where it came from. Some comets dive into the sun, never can be seen again. When the comet is in the inner solar system, either coming or going, that's when we may see it in our skies.
Each comet has a tiny frozen part called a nucleus, often no larger than a few kilometers across. The nucleus contains icy chunks, frozen gases with bits of embedded dust. A comet warms up as it nears the sun and develops an atmosphere or coma. The sun's heat causes the coma's ices to change to gases, so the coma gets larger.
The coma may extend hundreds of thousands of kilometers. The pressure of sunlight and high-speed solar particles, solar wind, can blow the coma dust and gas away from the sun.
The nucleus or solid part of a comet is usually less than about 6 miles across, but may be as big as about 25 miles across. Recent space missions have given us some close-up views, so we don't have to guess what they look like anymore. The Deep Space One mission found rugged terrain, smooth rolling plains, deep fractures, and very dark material on comet Borrelli in 2001. A few years later, space mission Deep Impact flew very close to comet Tempel 1. That comet also appeared very black on the outside, as black as the charcoal briquettes for your barbecue. What's inside a comet? Comets seem to contain a lot of ice, some rocks and dust, and some gas. Deep Impact crashed a smart impactor into comet Tempel 1 and studied the debris that spewed out. It found that the surface of the comet is very fragile and weak. Inside it is spongy with lots of holes. It has ice beneath its surface. It contains material from outer, middle and inner parts of the solar system. Other comets may be different. Thank you.
Why do comets have tails? Comet tails appear as the comet approaches the sun and can grow to be millions of miles long. The particles in the solar wind push the small dust particles in the coma into a long curved path. This tail is known as the dust tail. Another tail, the ion tail, is made of electrically charged molecules of gas. The ion tail directly points away from the sun.
How comets get their name? Comet naming can be complicated. Comets generally get their name for their discoverer, either a person or a spacecraft. This International Astronomical Union guideline was developed only in the last century. For example, Shoemaker-Levy 9 was named because it was the ninth short periodic comet discovered by Eugene and Caroline Shoemaker and David Levy. Since spacecraft are very effective at spotting comets, comets have linear, SOHO, vice as their name. Thank you.
Halley's Comet. Halley's Comet is the most famous of all comets. British astronomer Emmett Halley was the first to realize that comets are periodic. After observing it in 1682 and tailing it to two records of two previous comet appearances, he correctly predicted it would return in 1757. The comet is also to be depicted in the 1066 Bayes tapestry. Halley's Comet, which is 8 kilometers wide and 16 kilometers long, travels around the Sun every 75 to 76 years in an elongated orbit. It last passed close to Earth in February 1986. Shoemaker-Levy 9. Comet Shoemaker-Levy 9 distinguished itself by breaking into 21 pieces under the stresses of Jupiter's gravity in 1992 and then slamming in suction into a giant planet in 1994. The spectacular show was watched by telescopes across Earth in orbit and abroad space through Galileo. The impact of one fragment around 3 kilometers across is said to have yielded an explosion and fireball equating to 6 million megastones of TNT. The plume reached 22,000 kilometers above the cloud tops.
Yakutake, an icy blue blob with faint gas tail, created the most spectacular comet display for 20 years as comet Yakutake passed just 15 million kilometers from Earth in March 1996. It was the closest comet that had come to the Sun in 9,000 years. The comet left astronomers puzzled as it produced X-rays 100 times more intense than predicted.
Comet Hale-Bopp made its closest approach to Earth for 4,000 years in January 1997. Hale-Bopp is much larger than Halley Comet. It has a nucleus up to 40 kilometers in diameter and could be viewed from Earth with the naked eye.
Comet Borley. After Halley's comet, Comet Borley was only the second to be spied close up by a spacecraft. NASA's Deep Space One paid a visit in 2001 and gave researchers a detailed glimpse of the comet's pitch black core. Its snapshot revealed that the rocky nucleus is shaped like a giant 8-kilometer long bowling pin, and the entire comet is curiously lopsided. Unlike Halley's comet, which formed in the Oort cloud at the outer edges of the solar system, Borley is believed to originate in an icy cloud of rocks beneath Neptune called the Kuiper Belt. Comet NK. Comet NK was the second comet discovered to be periodic by German astronomer John Franz Encke in 1819. The comet is also the parent body of the annual Turin meteor shower in October and November. It is a relatively old comet that now gives off little gas.
Let's watch a dance about comets.
Wow! Here I go!
Come on, come on, come and be comets.
Oh!
Come and be comets.
Fly, 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 comets with tails. I see gas like a huge snowball. Near the sun, I'm out with a tail. Fly, 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 comets with tails.
Fly, fly, comets with tails, round the sun like a wanderer. Near the sun, it glows with our tails. Fly, 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 comets with tails.
Wow! What a universe! Wow! Here I go!
Come and be comets.
Oh!
Come and be comets.
Fly, 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 comets with tails. I see gas like a huge snowball. Near the sun, I'm out with a tail. Fly, 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 comets with tails.
Now let's see what our friends are going to share about galaxies.
A galaxy is a huge collection of gas, dust, and billions of stars in their solar systems. A galaxy is held together by gravity. Our galaxy, the Milky Way, also has a supermassive black hole in the middle. There are many galaxies besides ours, though. There are so many we can't even count them all yet. The Hubble Space Telescope looked at a small patch of space for 12 days and found 10,000 galaxies of all sizes, shapes, and colors. Some scientists think there could be as many as 100 billion galaxies in the universe. Some galaxies are spiral shaped like ours. They have curved arms that make it look like a pinwheel. Some galaxies are smooth and oval shaped. These are called elliptical galaxies. And some galaxies are not spiral or oval shaped. These are called irregular galaxies and look like blobs. The light that we see from each one of these galaxies comes from the stars inside of.
Sometimes galaxies get too close and smash into each other. Our Milky Way galaxy will someday bump into Andromeda, our closest galactic neighbor. But don't worry, it won't happen about 5 billion years. But even if it happened tomorrow, you might not notice. Galaxies are so big, spread out at the ends, that even though galaxies bump into each other, the planets and the solar system often don't get too close to colliding. Nature has provided an immensely varied array of galaxies ranging from faint, diffuse, and rough objects to brilliant spiral-shaped gems. Virtually all galaxies appear to be formed soon after the universe began, and the private space even into depths of farthest reaches penetrated by powerful modern telescopes. Galaxies usually exist in clusters, some of which in turn are grouped into larger clusters that measure hundreds of million light years across.
Spiral galaxies look like the giant pinwheels. The arms of the pinwheels are made up of stars and a lot of gas and dust. Gas and dust are some of the main ingredients needed to form a new star. Young stars burn much hotter than the older stars, so spiral galaxies are often some the brightest in the universe. About 20% of all galaxies are perennial. Our home galaxy, the Milky Way, is a very good example of one.
Elliptical galaxies are shaped like stretched out circles or ellipses. Some elliptical galaxies are more stretched out than others. One might look almost perfectly circular. Another one might look long and flat. Elliptical galaxies contain mostly older stars. That means they often are not as bright as spiral galaxies. They also have very little dust and gas. Elliptical galaxies are the largest and most common galaxies observed. They make up about 60% of all galaxies. One of most famous elliptical galaxies is Cygnus A.
In general, irregular galaxies contain large amount of gas and dust and can exhibit a significant degree of stars formation activity. The closest galaxy to the Milky Way happen to be a irregular galaxy called the Canis Major Drift. With just 1 billion stars, it appears to be a small galaxy in the process of being consumed by our own galaxy.
Now let's listen to a beautiful song about galaxies.
And then the four most common shaped galaxies, spiral, irregular, barred and elliptical.
Like the wheels in the sky made of millions of parts, each galaxy contains billions of stars. Our solar system is a star apart. Milky Way galaxy is a spiral. Galaxy will form into many shapes. Spiral has a bright wheel round in a way. Two arms it may before they bend. Very distant above stars out each end.
Elliptical, yes, they will vary in shape. Round to oval, red stars they contain. Irregular is a cloud with no shape. Stars have no pattern, not seen anyway. Turn the lights down low. Search the skies aglow. We can see so far from so close.
Like wheels in the sky, star clusters so bright, spinning through time, faint to naked eye. And then the four most common shaped galaxies, spiral, irregular, bar and elliptical, like wheels in the sky. Stars are so bright, Stars are so bright, like wheels in the sky.
Milky Way galaxy, it is fairly large, 100,000 light years it is from the spiral galaxy. Yeah, you know its name. Atoms to milk for spilled in its sky. They say the Milky Way is what we all call home. Out and an arm, no, we're not alone. We lie about 30,000 from the start. Glowing pink, blue, green glasses, nebulae. Like wheels in the sky, star glasses so bright, spinning through time, faint to naked eye, and in the foremost common-shaped galaxies, spiral, irregular, forward and elliptical, like wheels in the sky. Stars are so bright, the stars are so bright, like wheels in the sky. In the sky, star clusters so bright, spinning through time, faint to naked eye, and then the four most common shaped galaxies, spherical, irregular, varied, and elliptical, like wheels in the sky. The stars are so bright, the stars are so bright, like wheels in the sky.
Like wheels in the sky, star clusters so bright, spinning through time, faint to naked eye, and then the foremost common-shaped galaxies.
Oh, we have gathered a lot of information about galaxies and listened to a beautiful song too. Now let's see what is artificial satellite.
When we look at the night sky, many heavenly bodies like stars, moon, satellites, etc. are observed in the sky. Satellites are small objects revolving or orbiting around a planet or on moon is the satellite of Earth. As the moon orbits around the Earth in its fixed orbit, satellites are objects that either occur naturally or man-made that used to go around a planet that is larger than it and rotates it in its axis. There are various satellites, including the moon, present in the solar system. Therefore, on the basis of extent, satellites divided to many characters. Natural satellites, any celestial bodies present in space that revolve around a planet larger than its fixed and orbits around is called the natural satellite. The solar system consists of 6 planetary satellites, system out of which 205 satellites known to be natural satellites. These satellites are elongously larger and orbit in large radii. Their surfaces are generally made up of various gaseous rocky mountains.
Geostationary satellites. These satellites are high-orbit satellites that orbit around the Earth approximately 36,000 km away. The geostationary satellites are called so because geostationary satellites revolve in an equatorial linear orbit, due to which they orbit around the Earth at the same rate as the Earth rotates. Some examples of such satellites are INSAT of India, Geostationary Operational Environmental Satellite of USA, Himawari of Japan, Meteosat of Europe, etc. Polar satellites. These satellites are low-orbit satellites that orbit around the Earth approximately 500 to 800 km away. A polar orbiting satellite passes near to or directly over the pole on each orbit.
With the Earth turning underneath it, this means that the polar orbiting satellite sees a different bit of the Earth each time. Such satellites are used to study the universe, help forecast the weather, transfer telephone calls over the oceans, assist in the navigation of ships and aircraft, monitor crops and other resources, and support military activities.
Types of artificial satellites on the basis of the direction of the motion of the satellites and the distance from the Earth's surface. Artificial satellites broadly classified into two: geostationary satellites, the artificial satellites that rotate in the same direction as the Earth in a prefixed orbit, which is around 35,800 km away from the Earth's surface, are called geostationary and geosynchronous satellites. Polar orbiting satellites, the artificial satellites that orbit around north and south orbit passing over north and south pole is approximately 500 to 800 km away from the Earth's surface, are called the polar satellites.
Satellite design. Every satellite has some of the same basic parts, the bus. This is the frame and structure of the satellite to which all the other parts are attached. A power source. Most satellites have solar panels to generate electricity. Batteries store some of this energy for times that the satellite is in the shadow of the Earth. Heat control system. Satellites are exposed to extremely high temperatures due to exposure to the sun. There needs to be a way to reflect and radiate heat. Electrical components of the satellites can also produce a lot of heat. Computer system. Satellites need computers to control how they operate and also to monitor things like altitude, orientation, and temperature. Communication system. All satellites need to be able to send and receive data to ground stations on Earth or to other satellites. Curved satellite dishes are also used as antenna. Altitude control system. This is the system that keeps a satellite pointed in the right direction. Gyroscopes and rockets, thrusters, and are commonly used to change orientation. Light sensors are commonly used to determine what direction a satellite is pointing. A propulsion system. A rocket engine on the satellite may be used to help place the satellite into the correct orbit. Once in orbit, satellites do not need any rockets to keep moving. However, small rockets called thrusters are used if a satellite needs to change orbit slightly.
Difference between natural satellites and artificial satellites. These satellites are naturally occurring objects. They are man-made. They cannot be controlled by humans and so have no use. They can be controlled by humans and so have wide applications. The natural satellites can be communicate on Earth with other planets. The artificial planet can communicate with instruments on Earth. The natural satellites is made up of natural material like gases, rock, mineral, water, dust, etc. The artificial satellites is made up of metal and electronic materials. The natural satellites like planets are opaque bodies with no light with of their own. They also receive that heat and light from sun like moon. The artificial satellites are objects humans propel from the Earth in order to orbit. Around the Earth, the electrical power required by satellites is provided by panels, solar cells, and small nuclear reactors.
Hello everyone. Today we are having an interview with our satellite experts. Let us do an interesting talk with our experts. Hello Mr. Nikhil. Welcome to our studio. I welcome you on behalf of my audience. Let's start. Sir,
What is an artificial satellite and what are its uses?
An artificial satellite is an object that people have made and launched into orbit using rockets. There are currently over 1,000 active satellites orbiting the Earth. Here I want to show you few satellites. 2019 Chandrayaan-2, India's second lunar exploration mission. 2019 Cartosat-3. Cartosat-3 is one of the optical satellites with the highest resolutions in the world. 2020 GSAT-30. GSAT-30 is the 41st communication satellite launched by ISRO, replaced INSAT-4A. It provides advanced telecommunication services to the entire Indian subcontinent. 2020 EON-01. It is an Earth observation satellite. Uses of satellite. Television. Satellites send television signals directly to homes, but they are also the backbone of cable network and TV. Telephone, navigation, business and finance, weather, climate and environmental monitoring, safety, land stewardship.
Thank you, Mr. Nikhil. You gave such a good piece of information. Now, Mr. Rakachandru will give some information about Aryabhatta, India's first successful satellite.
The launch of India's first indigenous satellite, Aryabhatta, 46 years ago on April 19, 1975, is celebrated as a landmark in the country's space program. Aryabhatta was India's first satellite named after a famous Indian astronomer. It was launched on 19 April 1975 from Kapustin-Yar, a Soviet rocket.
Wow, that was great information. Thank you, sir. Thank you all for the great information. Now, we end the interview.
It's quite interesting. Now let's see what our friend is going to say about space debris.
Space debris. Space debris is space junk, space pollution, space waste, space trash or space garbage. Is non-living artificial objects in space, mainly in Earth orbit, which no longer serve a useful function. It includes rundown spacecrafts like non-functional spacecraft and abandoned launch vehicle stages, mission-related waste, and particularly mainly in Earth orbit. Fragmentations, debris from the breakup of disused rocket bodies and spacecraft. In addition to rundown man-built objects left in orbit, other examples of space debris includes fragments from their breakup, elution and collusion, or even paint spots, solidified liquids expelled from spacecraft, and unburned particles from solid rocket motors.
It was an amazing experience to learn a lot of new facts and information about space. Thank you, friends.